In this video, we're going to take a look at the final part of the Cheat Engine built-in tutorial series, which concludes with a mini-game. It has 3 levels and it allows us to apply the techniques from the earlier tutorials to a real game. If you've been watching up until now, you'll know that we've been doing that anyway with Cave Crawler, but this will reinforce some of the things that we've learned. As you can see, I've got the Cheat Engine game open at the moment. You can open this through the help menu with Cheat Engine tutorial games, or you can just follow through the tutorial and this will come up after part 9. And we want to make sure we've got Cheat Engine connected to the tutorial. We do that and let's have a look at what step 1 is. It says, after 5 shots you'll have to reload, after which the target will heal. Try to find a way to destroy the target. And then we can click to hide that. So in most cases where you're doing this game hacking stuff, there'll be various possible avenues of exploitation. So in this case, we could potentially increase our ammo. So instead of only being able to shoot 5 bullets before reload, we could increase this value so that we can shoot 10 before needing to reload. Or we could potentially increase the damage that the bullets do. We could reduce the health of the target. Or we could just inject some instructions to say that the target should die after 1 hit. Something like that. So let's first of all find a value. Let's start this off. We don't know what the initial value of this health is. We do know that this is showing a 5, but what I'm going to do is go to unknown initial value, leave it as 4 bytes, and we'll do our first scan. We've got over 10 million results. That's quite a lot. So let's try and do some damage. You can see some damage has been done, so now we're going to say that the value has decreased because we don't know what the health started out as. Maybe it's 100, but we don't know for sure, so we'll say it's decreased. And then we could say unchanged now because it's not changed since then. We can put that on repeat so that it keeps going through. And you could go and do some other actions. So why don't we try and move this around? Why don't we try and shoot some bullets but not at the target, so the target's not losing health. But we've still got a lot, there's 28,000 there, so let me turn that repeat off. Let us say decreased value, and then I'll shoot the target again. There we go, let's go next. And now we've not got very many results, and this 152 looks interesting because that would make sense. It looks like it's lost about half of its health. So why don't we try and do some damage again? And you can actually see that went back up to 100. So that looks like it is of interest to us. Let's find out what writes to the address. And let's go ahead and do that again. You see, as soon as it got hit, it took some damage. We can see the values that are in the register here. We can open this up in the disassembler and try and find out what's going on. One thing that's interesting, did you notice what happened there? So this is moving the value from EDX into this pointer, the address pointed to by the RAX plus 70. If I go now show disassembly, see here's the instruction, move EDX into RAX plus 70. If I scroll up, it's disappeared. So the instruction just suddenly disappears. Oh, it came back, move EDX, scroll up again, and again it's disappeared. I can't really work out why that was happening. Another thing we could do would be to go back and say we want to find out what accesses the address, do the same thing again, and in this case we're going to get more results, and we might want to try and find one that has a subtract instruction and see what value is being subtracted from the health and see if we can just increase it. I don't actually see that there, maybe that's happening with the CVT-SI2SD instruction. I'm not really sure what that is, I'd have to go and Google it. Let's open up this one again. So this is the one we were looking at previously. Moves the value. So the EDX holds the value, it's been moved to RAX plus 70. We show it in the disassembler, and then we have this comparison instruction where it's comparing whatever's in the RAX plus 68 to 0. And if they equal, it's going to jump down to here. Otherwise, it'll continue with this stuff. So maybe we could just say, alright, rather than actually doing that check, why don't you just jump regardless? We'll just say, just jump. Alright, let me try and shoot it again. And actually, nothing happens now. So that wasn't good. So it was jump if equals. Whenever I change to jump, we get no damage at all. So let's say jump if not equals. Okay, we try and shoot it. And it's still taking no damage apparently. Let me just put that back to jump equals. So we can just play around with these values and see how they work. Alright, so that's done damage. but now whenever I reload, it's re-healed again. Let's try and go back and let's just change the value that we have here. So the value is currently 100. What if I just change the value to 1? So the health should now be 1, but there's nothing to update it. So let's try and shoot it and see whether that destroys it. And it does. Alright, so that's one way of solving that. There are multiple ways of solving it. The last time I looked at this, I actually went and changed one of the instructions from jump if less than to jump if greater than, and then it just meant that each time you shot it, it killed the enemy first time. So step 2 says, these two enemies have more health and do more damage than you do to them. Destroy them. And then we get a tip/warning which says enemy and player are related. So we've been through some code injection stuff and some shared code in previous videos, so it looks like we'll need to apply some of that here. We can see our health value this time is 100, so I'm going to change this to exact value scan. We'll do a new scan, and the first value we're looking for is 100. We get 157 results, so let's take some damage. I'm going to shoot over here. You see we take some damage. We're at 96. Next scan, there's only one value, so this is our health. Let me get rid of that first value. This is our health here. We could verify that. Let's put that up to 1000. We don't see anything happen, but let's go and try and take some damage. And now it goes up to 996. So one thing we could do is just to freeze this value, and we can just play the game now as normal. We're not taking any damage, but they are taking damage. But as you can see, that's going to be a very slow way of solving it, so let's try and do something different and take advantage of some of the other things that we've learned, which were the code injection, for example. So let's do our find out what accesses this address. We could also do that with writes as well, but we'll get less results. Here we have the subtract instruction, so that one's going to be interesting to us. We'll open that up in the disassembler, and then we want to find out what addresses this instruction accesses. And again, I'm going to take some damage, so I'm not going to damage the enemy player, so we want to find out where the address of our player is. So I'm going to do Control and 1. You can also just right click and do mark as group 1, so that's us. Now we're going to shoot both of the enemy players, and now we have those two results. So we could mark them with Control and 2, or we can just, because there's only two groups, we could just also just scan as well. You can right click and go to scan for commonalities, or Control Alt and S. And what we're interested in finding out is, are there any shared values here? So every time the enemy player loses health, is there some register that has a value, which whenever we lose health, that value is not the same. So in this example, you have RDX, it says group 2 has a common value 0x1, which means that every time the enemy player takes damage, the RDX has a 1. Every time we take damage, the RDX doesn't have a 1. So that's a condition that we can use to basically go and write some code and say, if the RDX is this, then do this, otherwise do this. And that's exactly what we'll do. So we'll go and use the auto assemble. So I did Control and A, and then we'll do Control Alt and T, and that will do the cheat table framework code so that we can add it as a cheat table. We'll do Control and I to inject code. And this comes up with our previous code. So this is what's happening originally. It's subtracting whatever's in the EDX from the RAX plus 60. And we want to basically add a condition here. So this is where our code goes, and we want to say if, no, we're not saying if, that would be normal coding. Let's do our assembly. So we're saying compare what is in the RDX with 1. And if they equal, that means it's an enemy player. So if they equal, you could say jump if equal, and then we'll jump to this original code. And then if not, you could say jump exit. So if this is a 1, it'll go here and just take damage as normal. If it's not a 1, it means it's our player, and then it'll go and just jump to the exit without taking damage. However, this will actually crash the game. And I know that because I tried it earlier, and the reason being is because it's not only subtracting the health here, it's also got this return and this add instruction, and without those, the game will crash essentially. So what you could do is you could take a copy of this here and then just put it here. So we're basically saying if it's an enemy player, just go to the original code. If it's not, then we need to do this return and this add AL to the RAX, and then we'll exit. And then we can save this, we'll go and assign it to current cheat table, close that down, we can tick that, and now whenever we shoot the enemy player, you see they're taking damage, we're not taking any damage, so we could just continue with this as we are until they die. However, again, it's going to take a long time because they've got a lot of health, so let's try and come up with something better. So let me open this again, I'm going to right click, I'm going to change script, we'll go back here, and what we'll say is, if this is equal to a 1, if they compare this and it's a 1, it's the enemy player, which isn't really a great value. We should have probably used a different register as well, because the value that's in the RDX or the EDX is the amount of health to take away. So the only reason these were different is because the enemies take less damage than we take. But it could mean that if we stop playing around with the script and changing the amount of damage that we take or the enemy players take, this condition is going to change. So it might not be a great value to choose, but it's fine in this case. What I'm going to do, let me take this out, and let's say if it is an enemy player, actually I'm going to take this out of the original code, and I'm going to put that here. So we're going to say if it is an enemy player, alright, I'm going to change this to jump not equal. So if it's not equal to 1, it means it's us. And then it's just going to go and do this original code. Otherwise, it's going to subtract, and then it'll just do the original code anyway. So we've not really changed much at all. We've just moved this out of original code up to here, and then we've changed that. We've added this jump not equals as well. And that should be fine. Let me try that now. Oh, I didn't make it take more damage though. I didn't really change much there, did I? Okay. Let me go back. What I should have done is said, alright, rather than subtracting the EDX, let's actually subtract 64, which is 100 in decimal, and that means that they should just die instantly. There we go, there's one. This one's going to start sending mega bombs at me, but I don't think they'll do any damage. I want to actually see if they do. No, they don't. Okay, that's good. Alright, so now I just shoot it, and there we go, we've passed that level. Okay, on to the final level, and again, there are many different ways that we could potentially solve this. It says that we need to mark all the platforms as green to unlock the door. Enemies are one-hit kill, so if we touch an enemy, we instantly die. And it says there are multiple solutions, so you can find collision detection with enemies, you can teleport, you can fly, or, and then there's obviously more that we could do. So we'll close that, I'm going to untick this auto-assemble script, and what I'm going to do here is look for our Y position. So we have an X and we have a Y position, our horizontal and our vertical position, and it's normally a float value, so I'm going to change this to new scan, float, and then we'll say it's an unknown initial value because we don't know what it currently is. We'll do our first scan, and then we've got 13 million results, so we're going to say that it's increased, and I'm going to jump and then do next scan. Now it's decreased because we've landed, so I'm going to say next scan again. We could now say unchanged and do that repeat, and you can see it'll start filtering those out. We can move around without jumping because that's not affecting our Y position, and we now run it down. Again, I'll go and change this to, in fact we don't have many results left, let me just do it one more time. I'll do increased value, I'm going to jump, there we go, and then we'll do decreased value because we've landed, and now we've only got one result left. I'm going to remove these, and now let's jump and we'll see that that goes up, which is cool. Okay. Let me try and freeze it. Notice that? I can actually hold it in now, and it just keeps jumping higher. So that's pretty cool. What you can also generally do here, if I right click and go to Browse Memory Region, and you can quite often find the X position near the Y position as well, so I don't know if it'll work in this case, but whenever I jump, you see we've got this 0 goes to a 1. Quite often whenever you move left or right, you would see a value near it changing. That's not the case here, probably because of the value that I have selected. But we could do that with the enemy players as well, so we could say we want to try and find a new value. We've got an unknown initial value, first scan, and then we could wait until, because this is moving to the left at the moment, we could wait until it's moving to the right and assume that is going up. So let me do a new scan, because I don't know. I'm going to wait till it's over at the left. Alright. Oh, I meant to do unknown initial value. And then I'm going to say increased value. There we go. I'm going to say decreased. So I'm waiting for this to move over to the left again. There we go. And then increased, waiting for it to move over to the right. You could slow this down using a speed hack, or you could use backslash as well to pause the game. We've got 333 left now. I'm not actually sure where the where I did the last one at, which isn't good. I'll try and do it right at the end. Okay, and then increased. Alright, and then decreased. They're moving a little quick, so you might not even really see exactly how I'm trying to do this. Okay, let me do the speed hack as well. Enable speed hack. This kind of causes it to slow down a bit. Apply. Alright, so they're going nice and slowly now. This could help us just finish the round as well. Alright, so I'm going to go increased. There we go. Decreased. I'm waiting for this to go all the way over to the left. Or well, we just need to go down to the left a little bit more. And hopefully that is that. Let's go increase this time. I'll wait for it to move back over. Alright, we've got 2 there. Let's try and move those down. I'm going to turn off the speed hack. And what happens if we freeze it? There we go. That one's frozen. Freeze that one as well. I don't know. Okay, we only got 1 of them there. Let me turn that one off and let's see if we can browse the memory region for this one. Or we can find out what is right into this address and then find out what addresses this opcode accesses. So now we've got 3. Let me add these. Alright, so we've got these 3 now. Let's tick those. Alright, so now they're all just frozen still. We could probably move these over as well. Can I do like 1? Where does that go to? Alright, so that's like glitching up there. Do you see that? Okay, so yeah, there's a few different ways you could do it. That's probably okay for me now. Where did I... Okay, let me freeze. Okay, yeah, there we go. I could probably still die from these things though, but that's fine. So yeah, we've kind of done like a little fly hack there. Just holding space to fly up, and we've also frozen the position of the enemies just to... Oh my god, I nearly still died. Wow, okay. And then we just go over to the door at the end. And there we go. We have completed all 3 games. And that's going to wrap it up for the 10th video in the Cheat Engine series. We've been through all of the built-in tutorials, and we applied the techniques that we learnt in them to Cave Crawler, and we also completed the minigame at the end of the Cheat Engine series. So I'd really like to make some more videos. If you are interested in that, please do let me know your recommendations. Would you like to see some Lua scripting or dissecting mono features from Unity games? There's a lot of things that we could cover. I'm also going to have a look at some other elements of game hacking, so things like injecting DLLs and looking at network traffic, things like that. But yeah, I hope you've enjoyed this series. If you have any questions or comments, as ever, leave them down below. Thanks.